So we're going to go ahead and go over homework 11, and then the rest of the class period, you can do your midterm. First one's they're talking about the discrete probability of a distribution. What they want you to know is if I have a distribution, the total probability always has to equal 1 because it's 100%. So what they want you to do is fill in two possible answers that you could put in for these values so that everything would add up to 1. So first thing you're going to do is just go ahead and take 1 and subtract off the ones that you know. So we know that one's 0.16, one is 0.11, and the other one is 0.20. If you take 1 and subtract those 3 that we already know, that's going to tell you how much we have left to divide up between our two other numbers. So if you took 1 and you minus the 0.16, minus the 0.11, and minus the 0.20, what did you get? 0.53, right? Now, it doesn't matter which combination you do to add up to 0.53, you just have to pick two values that would add up to 0.53. So just give me a number to put in there for 1. What?
I don't know.
Maybe we want it to be 0.3. If this one is 0.3, what would this one have to be?
7.
It has to add up to this.
Oh, 0.13.
Try that again. 0.23, right? So you can put in any pair of numbers as long as they add up to this, so that all 5 of your values should always add up to 1. 100% of your information. Okay? Oh, just do second function in mode to get back to your home screen. Then you can clear it. Second home gets you back onto the regular screen to tape on. All right. So number 2, same kind of thing. They just want you to realize that all 5 of these numbers here have to add up to 1. So we're going to first start off by taking 1 and subtracting off the ones we know. 0.16, 0.24, and 0.22. How much do we have left for our other 2? 0.38. So now we're going to pick any 2 numbers that add up to 0.38. Pick one for the first one. 0.21. Okay. If that one's 0.21, what would this one down here have to be in order to add up to the 0.38? 0.17, right? The 0.21 plus the 0.17 add up to 0.38. If you added all 5 of them, they should add up to 1. So it doesn't matter which pair you use as long as they add up to what we have left here. So number 3, same kind of thing. I know that in my table, all of my numbers should add up to 1. I'm going to take 1 and subtract the ones I already know. And that's going to tell me how much I have left to divide up between the other 2. .42. And so if I have 0.42 and I need to distribute that to those 2 values there, which 2 numbers might I possibly use? 0.20 and 0.22 would be good choices. Any 2 that add up to that number, doesn't matter what 2 you use. Okay? So number 4, now they're going back to that probability of flipping a coin. An ordinary fair coin is tossed 3 times. The outcomes are thus. Triples of heads, tails, which we write as heads, tails, 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 etc. For each outcome, let R be the random variable counting the number of heads in each outcome. For example, if I have the random HHT equals 2, that means it happens 2 times. It tells us that x is defined by the following: 2r minus 2r squared minus 1, which we really don't care. All we're really going to do is fill in our table to list what our probabilities are. So, the first ones are your values of x. In other words, what numbers do I have in this table? Well, in this table I have a -1. I'm going to write it above there since it's probably easier to read there. I have a -5s. And I have a -13. The second row, I'm just going to write the probability in as a fraction. We have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. How many -1s did we get? 1, 2, 3, 4. So 4/8, which is a half, right? For our -5, we've got 1, 2, 3 of them. So our probability, 3/8. Put it underneath there so you can read. And for the 13 then, what would be our probability of getting -13? 1/8, right? 1 out of 8. So they give you all that weird stuff and talk about that weird formula, you don't even use it. All they're trying to do is have you take the information from this table and write them as their percentages as a fraction. So number 5, same kind of thing. We tossed a coin. It gave us the outcomes. And so this time we only have 2 possible answers. The 2 possible numbers that we got are, looking in your table, -1 and -5. Doesn't matter which order you put them in. Right? Those are the only values that I have in my table for x, -1 and -5. And then we're going to do the probability of getting each of those. So for the -1 we have 2 out of 8, which reduces down to 1/4. For my -5 I have 6 out of 8, which reduces down to 3/4. Notice 1/4 plus 3/4 is 100% of my possibilities, right? So on number 6, this time they're doing boys and girls in 3 possible outcomes. Again, they gave us the table. They want us first of all to write one of our possible values of x. By looking at our table, what numbers would we have on our possible values of x? -4, -2, and -10. Whatever order, it doesn't matter which order you put them in. And then we're going to list their probabilities. So for the -4, I would have 4 out of 8, which is 1/2 then, right? For the -2, I would have 3/8. And for the -10, 1/8. And that's all I'm going to do with those, is just fill in the table. All right. Expectation and variance of a random variable. The expectation is like finding the weighted mean. We did the weighted mean before. The variance is your standard deviation squared. So it just gets rid of the square root from our standard deviation formula that we did before. So first thing we're going to do is figure out what the expectation is, which is basically the same thing as finding your weighted mean. -1 has a probability of 35%, so we're going to take -1 times 0.35. 0 has a probability of 0.05, so we're going to take 0 times 0.05. 1 has a probability of 0.45. 2 has a probability of 0.05. And 3 has a probability of 0.10. So basically we're just taking the value times its probability and then adding all that up. My expectation or my weighted mean is going to be what once I figure all that out? Try that again. It's not what I got. Yeah. I only have one negative number up there and it's not very big, so I'm thinking I'm going to get a positive answer.
0.5.
0.5, that's what I got. 0.5 is what you should get. So you took -1 times 0.35 plus 0 times this plus 1 times that plus 2 times that plus 3 times that. If you wanted to do it in 5 steps and add them together, you could. Now, the variance. Remember when we did the standard deviation, we had the square root of, and then we had that great big long huge formula. Same kind of thing is going to work here. We are going to take each of these values, subtract the mean and square it, and then times it by the probability. We don't have to do the square root thing because variance is the standard deviation squared, and when you square the square root, it gets rid of that. So, what we're going to do is we're going to take -1, we're going to subtract 0.5, we're going to square that, and then we're going to multiply it by that probability. Plus, then we're going to just do each of our numbers. So 0 minus the 0.5 squared times its probability. And we're going to do the 1 minus the 0.5 squared times its probability. The 2 minus the 0.5 squared times its probability. And lastly, the 3 minus the 0.5 squared times its probability. Now here you do need that in parentheses, but you could just do times 0.35 instead of putting the parentheses, because your calculator will know that. So once you get all of that punched in,
1.65.
1.65, that's what I came up with. 1.65. What that number really means, and it really doesn't make a whole lot of sense until you take the square root of that number. If you take the square root of 1.65, go ahead and do that for me. Not that you need it for this answer, but just to explain what's going on. Square root of 1.65 is about what?
1.2.
1.2. So 1.2 from the middle is where most of your values are going to lie, because that's what standard deviation is. Remember, we have a standard deviation of 1 and 2 and 3. Most of your values are going to be plus or minus 1.65 from the middle. Well, you can tell here that's not a very big spread. So yeah, most of my numbers would be in between here and here, right? All right. Number 8. First of all, we're going to find our expectation, which is basically finding our weighted mean by taking each of our values times its probability, adding them up. So 10 times the 0.30 plus 20 times the 0.25 plus 30 times the 0.15 plus 40 times the 0.30.
$24.5.
24.5, exactly what you should get. 20.4.5 is our expectation, is what they call it here. It's like the weighted mean. We're now going to find the variance. So when we find the variance, we're taking each of our values minus that expectation squared times the probability. So I'm going to start with 10 minus 24.5 squared times 0.30. And then I'm going to do 20 minus 24.5 squared times 0.25. And then I'm going to do 30 minus 24.5 squared times 0.15. And then 40 minus 24.5 squared times 0.3. $144.75. Again, if I was just checking out what that means, if I took the square root of 144, I'm just rounding it off, it would be 12, right? Square root of 144 is 12. So most values are plus or minus 12 from the middle. If I went 12, I'd be about like that bigger range. We can see that would make sense. Plus or minus 12 from the middle would include most of our values. I don't know why they have you do variance. It really has no meaning to anything unless you actually do the standard deviation, but they do. So number 9, again, first of all, we want to find our expectation. So if we're going to find our expectation, what are we going to do?
Got an extra page.
You have you never know when you get copies. Sometimes you have an extra page, sometimes you're missing a page.
You're going to take 40 times 0.15, 50 times 0.40.
And so forth, right. We're going to take each of our values times its probability and add it all up. And that's going to find our expectation, which is like your weighted mean. Mean is your average. think that might have been one of your questions on one of your homework things. Is what are you finding when you're finding the expectation? And you're going to put mean.
Is it 59.5?
It is 59.5. All right, then we're going to do the variance. In order to find the variance, what are we going to do?
Take 40 minus 59.5 squared times 0.15
Mm-hmm.
plus, yeah,
50 minus the 59.5 squared times our 0.40. And then we have 60 minus 59.5 squared times 0.10. 70 minus 59.5 squared times 0.05. And lastly, 80 minus 59.5 squared times 0.30.
so 224.75.
224.75. To me, when I looked at that, I thought, geez, that number seems really big, but if you take the square root of that number, what do you get? So most of our values are from the middle are within 14.99, about 15 from the middle. Well, that makes more sense than 224.75. Most of them are within 15 from the middle. All right. Now they're actually going to talk about mean and standard deviation. So again, the mean is the average. Standard deviation, how far from the middle is your spread? In this case, the mean, the symbol for mean looks like that weird U-looking symbol, is you're going to take the number of people sampled times the percentage. So the mean's pretty easy to find. It says the workers' union at a certain university is quite strong. About 96% of all workers employed by a university belong to the workers' union. Recently, the workers went on strike, and now a local TV station plans to interview a sample of 10 workers, chosen at random, to get their opinions on the strike. Estimate the number of workers in the sample who are union members by giving the mean of the relevant distribution, that is, the expectation of the relevant random variable. Do not round your response. Well, all we're going to do here is take 10 times our 96%, and so we're going to get 9.6. The second part is going to ask for the standard deviation of your distribution. The standard deviation, you're going to do the square root of your n times p times 1 minus p. 1 minus p is when you do what's called the complement of that. 1 minus 96% is 4%, right? So in my formula, I've already figured out the n times the p was 9.6. I'm going to take that times the n, or the 1 minus p, which is my 4%, 0.04. You could write it out the long way if you wanted to. 10 times 9.6 times 1 not 9.6, that's 0.96. 0.96. Probably in the book they're going to write it out like that, the long way. But we've already done this times this to get this, and here we're just subtracting. So I would take the 9.6 times the 0.04 and then do the square root of your answer. And you come up with what to 3 decimal places it says.
Point 6. 3 decimal places?
Yep,
Point 20.
that's what I got, 0.620. So again, that's the long way of interpreting the formula, but we've already found the NP for answer A, and then we can just subtract from 100% to get that second part, unless you want to do it the long way. You can get the same answer either way. All right, Anita's fast food chain specializes in hot dogs and garlic fries. They're keeping track of the proportion of the customers who decide to eat in the restaurant as opposed to ordering food to go, so it can make decisions regarding the possible construction of an in-store play area, the attendance of its mascot Sammy at the franchise location, and so on. Anita reports that 45% of its customers order their food to go. Suppose that this proportion is correct and that the random sample of 50 individual customers is taken. So, estimate the number of customers in the sample who order their food to go by giving the mean. So I'm going to have N times P. My N is 50, the number of people sampled, and the P is 0.45, the 45% that ordered their food to go. 22.5. Then is your mean. Second part, we want to estimate the standard deviation of our distribution. Our formula says we're doing N times P times 1 minus P. And so if I plug my numbers in there, N times P was the 22.5. And what would I use for 1 minus P? If 45% ordered their food to go, how many didn't order it? 55, right, 0.55, exactly. 1 minus 0.45. 45 ordered to go, 55 did not order it to go. They stayed in store. And so, to 3 decimal places we get
3.518.
3.518. All right. Number 12. At a recent meeting at the American College of Asthma, Allergy, and Immunology, researchers reported that allergy vaccinations are effective in treating sinusitis, inflammation of the membrane of the lining of the facial sinuses, in individuals predisposed to allergies. Specifically, the researchers report that 98% of the individuals predisposed to allergies find relief from the sinusitis after allergy vaccinations. Suppose that this number is accurate and that 140 individuals predisposed to allergies are chosen at random and given the allergy vaccination. Estimate the number of individuals in the random sample who do not find relief from their sinusitis. They're trying to be tricky on you to see if you're reading. N is going to be 140. What percent do not find relief? 0.02, exactly. So they gave us the percent who found relief, but in the question they wanted the percent that do not find relief. So when we find our mean, then we're going to have
144 times 0.02. Or 140.
140 times 0.02, which gave us 2.8. We're then going to find the standard deviation, n times p times 1 minus p. So n times p was our 2.8. And what number are we going to use for the 1 minus p?
0.72.
Oh, you got your answer? No? Where did you get that number from? What number is going to go in here for the 1 minus p?
1.8.
Point 98, right? If this was 2%, then this is 98%. 1 minus 2% is 98%. So we're going to take our 2.8 times our 0.98 and take the square root of that answer and round it off to 3 decimal places. Try that again.
Oh, shoot.
Oh, your square root is above this key right here. So you would do second function square root, and then see that says ANS, second function answer. That will be the square root of your answer. Second function square root, second function ANS.
Is it 1.657?
Yep. 1.657. So the P and the 1 minus P should always add up to 100%. If this is 2%, that's the 98%. 1 minus that 2%. All right. The next ones, now we get to see if we remember how to do combinations on our calculator. Unless we want to do them the long way. I don't think so. We are going to do binomial problems basic, they say. Suppose that the New England Colonials baseball team is equally likely to win a game as not to win the game. If 5 Colonial games are chosen at random, what is the probability that exactly 3 of those games are won by the Colonials? So what we're going to do is first of all figure out the combinations of ways that we can do this. We have 5 people, chosen 3 at a time. So we're going to figure out that number. Do you remember how to do that on your calculator? I got to look at the calculator.
10.
10. Yes, 10 is the answer. So, in order to do that, what did you do?
I went to math.
You went, first of all, you put in the 5, right?
Oh, yeah.
5 math. Then we cursored over to the probability on the top. And number 3 is your combination. See that? Okay, I hit number 3. And then this one, we're actually going to type a 3 because we want to do the combination of 3 things if we have 5. And when you hit equal, you get 10, right? Okay? We are going to multiply that then by the probability of each of those things, one that it does happen, one that it doesn't happen. So in this case, since it's an equally likely to win the game, they have a 50% probability, right? So I have 50% probability that they'll win the game and a 50% probability, this one's going to be to the second power because they did a total of 5 games. Now again, these 2 things should always add up to your 100%. Most of the time they give you the percentage, but here they just said it was equally likely, so we have a 50% chance of winning and a 50% chance of losing. And so that's what we're going to do, is we're going to take 10 times 0.5 to the third times 0.5 to the second. Win, lose. And we are rounding these off to 3 decimal places again.
0.31. 3.
313, yep, 0.313. Okay, number 14, going to be the same kind of thing. TV executives is interested in the popularity of a particular cable TV show. She has been told that a whopping 68% of American households would be interested in tuning into a new network version of the show. If this is correct, what is the probability that all 6 of the households in her city being monitored by the TV industry would tune into the new show? Assume that the 6 households constitute a random sample of American households. So, first of all, for my combination, I would have a combination of what? How many total? How many households?
6.
6. And how many are going to monitor the TV industry? All 6 of them. So we have a combination of 6 out of 6. All 6 out of the 6 that we had to choose from. What do we get when we do that? 1. 100% of them are going to say yes. No. So we are then going to do that times our probability, 68%, and all 6 of them are going to do that. Then we're going to use the percent that are not going to. The percent that are not going to, if I take 1 minus 0.68, I get 0.32, and nobody's going to do that option because all 6 of them are doing the first option. So we're going to take 1 times 0.68 to the 6 times 0.32 to the 0. .099. Yep, that's what I got. So, 6 households, we want all 6 of them to say yes. 68% said yes, so 68 to the 6th power. 32% would be no, but we had nobody who chose that, so we had to the 0 power there. Now, let's see on number 15 then, if we can figure out our formula. So, he doesn't like me because I have that in my hand. Anita's a fast food chain specializing in hot dogs and garlic fries. Keeps track of the proportion of its customers who decide to eat in the restaurant as opposed to ordering food to go. So it can make decisions regarding the possible construction of an in-store play area. That seems like the same question, but that was the previous bunch. The attendance of the mascot Sammy at the franchise location, and so on. Anita's report that 52% of its customers ordered their food to go. If this proportion is correct, what is the probability that in a random sample of 4 customers at Anita's, exactly 3 order their food to go? So, first thing I'm going to do is figure out my combination. I'm going to do a combination of 4 things taken, 3 of them that are going to order their food to go, right? So combination of 4 things, and we're taking 3 out of the 4.
4.
And we get a 4. We are then going to multiply by its probability. Those who are going to order their food to go were 52%. And how many out of the 4 we're going to do that? 3. My other percent that are not going to order their food to go would be 48%. And how many out of the 4 are going to do that?
3.
Nope.
Or
1. 3, we're going to order it to go. That only leaves 1 left that is not going to order it to go. So these 2 numbers here should add up to your 100%. These 2 numbers here should add up to the total number of people that you sampled.
.26 or 70.
0.270, yep. That's what you should come up with. Okay? And the last three. These are the ones that I'm going to show you a shortcut if you log on to the Alex calculator. So if you're not logged into Alex, hop into Alex while I'm talking. It says, from experience, if an airline knows that only 85% of the passengers booked for a certain flight actually show up, if 8 passengers are randomly selected, find the probability that at least 6 of them show up. That means 6, 7, or 8 of them show up, right? Carry your intermediate computations to at least 4 decimal places. Round your answer to at least 2 decimal places. Note, the Alex calculator will allow you to compute this, and we'll tell you how to do that in a minute. If I'm not doing the Alex calculator, what I'm basically doing is what I did on the previous problems for each case and adding my percents together. So I would start off with saying, I have a combination of 8 people. If 6 of them are going to show up, I would find that number times the 85 to the 6th, and then I would do my complement, which would be 0.15 to the 2nd. That would be if exactly 6 showed up, right? Then we would do the 7. So we would have a combination, 8, 7 people, 85% to the 7th power, 15% to the 1st power, if 7 out of my 8 showed up. Then I would do my combination of 8 out of 8 showing up. So 0.85 to the 8th and 0.15 to the 0. So those are my 3 possible situations. If at least 6 of them are going to show up, 6 could show up, 7 could show up, or 8 could show up. I would probably figure out these numbers first and then do my multiplying and adding, just because I got to figure out that combination. So if you have 8 combination 6, 8 things taken 6 at a time.
Where's the calculator on here?
Where's the calculator on Alex?
Yeah.
Oh, you probably have to be on the problem. We're going to go to continue on my path. We'll get to that, but hit the drop down and see if you can find the ones that say binomial problems. Well, it may not let us do advanced, but we might be able to just use it on that problem there if the calculator's active. Yep, we'll be able to do it from that. First of all, we're doing it the long way. We'll get to the Alex calculator in a minute. So we're figuring out all of this. Basically this problem, and this problem, and adding our 3 answers together. It says round at least to 4 decimal places when you do each of your steps there.
So what do we do when we get the answer for the combination?
You got this answer here?
Yeah.
Which was?
28.
28. We're going to take 28 times this then. And then you'll figure out this one, and add your 3 together.
Okay.
Yes, we got to do our combination separately,
So
probably on our calculators.
like this, and then how do I do this part?
Okay, 0.65 to the, so you are going to use your caret key right there, to the 6th power, times, and in for, oops, well, no, we're going to put times. Put your times down. And then in parentheses, the 0.15 to the 2nd power. And hit equals. Okay. So for your first value here, you got to 4 decimal places, what number? .2376, is that what you guys are getting? Yep, okay. Let's try the next one. So again, figure out your combination first and then multiply. .3847. Getting that number? I didn't write down my numbers in between. And then do the last one.
.2725.
.2725. Everybody getting that? Maybe? Okay, add those up. And then once you add them up, then you can round your answer to 2 decimal places. 0.89. Now, that was really super fun and all to practice using that formula, but Alex gave you a little shortcut. Now I have to probably log into Alex. So, you have to find a problem, first of all, that you can get to your Alex calculator on. So just look on your drop down. Most of them probably have the calculator active. So whichever one you can get to the calculator on, I got my calculator up, you'll notice that you have this little weird thing here that says P for the probability, the B is it's a binomial one, the first box is your total number of cases, your second box is the percent that's going to happen, and then it's less than or equal to what number. Now on this problem here, which we can't see, but we had out of 8, we wanted 6, 7, or 8, which means that we really are going to have to figure out 0, 1, 2, 3, 4, 5, and do the opposite to get the 6, 7, or 8. So in our calculator here, when we do this one, did it let me, oh, it doesn't let me write and hit that at the same time. Close my ink. There we go. We had 8 total things, 8 passengers. The percent that they were going to book a flight and show up was 85%, and we're going to have to do less than or equal to 5. Because they only let you do the less than or equal to, it doesn't let you do the greater than. So, less than or equal to 5. When you put that in and hit enter, what do you get?
0.11.
You get what?
0.11.
Keep going.
Or it's like 0.1052.
0.1052?
Yep.
Okay. Always want to go to 4 decimal places and round off at the end. This is the ones that are less than 5. We really want 6, 7, or 8. So we're going to take 1 minus that answer. So if you do 1 minus your 0.1052, I always have one in my calculator in my hand and the Alex calculator.
0.8948.
0.89. That was the same answer we got when we did it the long way, right? So you have to be careful on your Alex calculator. It only does less than or equal to, so if you're doing something more than, you have to do 1 minus your answer. But certainly that was a lot quicker than having to do each of those cases separately, right? Probably. So, So, number 17 here. It says, a machine that manufactures automobile parts produces defective parts 15% of the time. If 6 parts are produced by this machine or are randomly selected, what is the probability that more than one of the parts are defective? More than one. That means 2, 3, 4, 5, or 6. Now, I probably don't want to have to do 2, 3, 4, 5, 6 the long way, right? I could if I wanted to. But if I do my Alex calculator, I want to do the probability of, how many items did we have? 6. The probability they are defective would be 0.15, and we want to be less than or equal to 1. If we think about these are the numbers we want to use, we're going to be less than or equal to 1. Now that's going to give us the probability of 0 or 1. We're really going to find that probability, so again, once we're done, we're going to take 1 minus our answer. So if you punch this into your Alex calculator and give me 4 decimal places, what do you get? 0.776, what was that? 5?
Yep, 6.
Okay, so now we're going to take 1 minus that answer, because this is the probability of 0 or 1. We want the probability of 2, 3, 4, 5, or 6. 0.22. Otherwise, you would have to do the combination of 6 things, taken 2 at a time, 15% to the 2, and 85% to the whatever, and you'd have to do 5 separate problems and add all your answers together. The Alex calculator makes it so you don't have to do all that long work, unless you really want to. So, 18. The manufacturer of a fertilizer guarantees that with the aid of the fertilizer, 65% of the planted seeds will germinate. Suppose the manufacturer is correct. If 8 seeds planted with the fertilizer are randomly selected, what is the probability that at most 5 of them germinate? So what does at most mean? 0, 1, 2, 3, 4, or 5 of them, right? Again, I could do all 6 ways of those separately, or I can use the Alex calculator. So on my Alex calculator, I'm doing my binomial distribution. I have a total of 8. The percent that they're going to germinate is 0.65, and I'm doing less than or equal to 5, right?
Oh.
This one I just get to use the number. These ones where I had to do more, the greater than, when I did less than or equal to, I ended up doing 1 minus. In this case, I don't have to do the 1 minus because I just want the answer for less than or equal to 5. So I'm just going to punch that into my Alex calculator and round it off to 2 decimal places. So we just have to go to 2 decimal places, so 0.57. So, if you're doing more than something, then you're going to do 1 minus. If you're doing less, in this case at most, then I just use the Alex calculator because it does calculate less than or equal to. So you always want to figure out where that cutoff is for that value to put in your calculator. Here we wanted to do more than 1. So there was our 1. At most 5. Alrighty,